Now the same numerical that we solved using equations, we are going to solve graphically. So how do we solve graphically? First you have x and y axis. What is there on x axis? Or normal stress, correct? So x axis will represent normal stress, y axis will represent shear stress. Now what is given in your problem? You are given angle of friction, you are given value of C, and you are given the sigma 3. So whatever is given, let's first mark on the axis. C will be marked. First what you do, you are given sigma 3 as how much? 100, no? So let's start marking here. Let's say this is 50, this is 100, okay? So 150, 200. So what all data we have marked now? First thing we did is we marked our x and y axis, try to keep it at the same scale. So I have taken 4 vertical lines equals to 100, right? That is my horizontal scale on x axis. I have taken the same scale on the y axis. If you do that, then only you can directly mark the phi. If your x and y axis are in different scale, you cannot mark this directly as phi, okay? Here then you will have to use phi is equal to tan inverse of y2 minus y1 upon x2 minus x1. That equation you will have to use, and then you will have to find out how much to mark and all. So don't do that. Instead of, best thing to do is try to keep your x and y axis in the same scale. Then C is 80, so I got it marked. And then sigma 3 is given to you as 100, so I got that also marked. The point at which sigma 3 is marked is named as A. Now the next thing is to draw the Morse circle. So how do we draw the Morse circle? First we need to find out where will be my center point, correct? Now how do we determine the center point? So this will require trials. So what you need to do, by trials, determine the center of Morse circle, that is a point on x-axis. A point on x-axis. You'll have to, what you'll have to do is take a pair of compass. Okay, let's say you keep the center of the pair of compass here. Okay, you keep the pair of compass and let your pencil point be on A. Okay, and then try to draw, like this is a circle, pencil point on A, try to draw a circle. See if it is tangential to this line. Are you understanding? So like this you draw a circle with this as a center. Not intersecting, maybe go a little farther. Again hold the pencil, center of the circle here. Okay, let the pencil go on A. Again try to draw a center of circle. So you keep doing this till you have your center of your pair of compass on x-axis passing through A, and when you draw the arc, it should be just tangential to this line. This line is called what? Failure envelope. Okay, where did you draw this line? In direct shear test you have drawn this line. Okay, so you do that. After that, what you do is, once you get, after using trials, you get a circle which is passing through A and tangential to failure envelope at the same time. Once you do that, then what you will get? You will get the center point. Let's say this is my center point. Okay, so let's say this is C, and now wherever it intersects on the other side, you call it B. So now by doing this, what have you got? You have got sigma 3 also. Sigma 1, sorry, you got sigma 1. Where is sigma 1? From this point B. From the point B to y-axis, you get sigma 1. Then once you get sigma 1, sigma 3, then what you will get? You get the exact value of radius. How much is the radius? Sigma 1 minus sigma 3 by 2. So you have anyway got this point C. From this point C, you draw a line which is tangential to failure envelope. Okay, rather you just draw a line from C to the point of interconnection between tangency between the circle and the failure envelope. So this has to be primarily 90 degrees. Okay. Now by doing this, what did you get? Now next thing is, see, there are two things which are asked in the problem. One is to find out deviator stress, and second is to find out alpha, right? Alpha F. So from after you draw this line, you will have to measure this angle. Whatever is this measured angle, that is given as 2 alpha. So you measure this angle. Let's say you get 2 alpha. You should get, we have already solved this analytically. So you should get this measured angle equal to 110. So alpha f will be equal to 55. More or less. You will not get exact value, but more or less you should get it as 55. Now once you know 55, you measure this sigma 1, you will get the value of sigma 1. It should be how much? 445 approximately. How much did we get in our analytical solution? Sigma 1, 440. No, how much you got it? See, 443 we got. So here you should get somewhere around 445. You can get 443 also. I'm just saying. You may get 443 exactly. Okay, so you got sigma 1, you know sigma 3, you know alpha. Next thing is to find out deviator stress. What is deviator stress given as? Sigma 1 minus sigma 3. So, the same problem can be solved using graphical